Comets, those icy wanderers, are supposed to act in a predictable way. They fly in, they get warmed by the sun, they sprout a tail of gas and dust, and they reflect a certain amount of light. But not all things are what they seem. For centuries, astronomers have tracked comets and watched their behavior align almost perfectly with the rules of physics. They brighten, they fade, and they follow a path we can model and expect. But sometimes, nature throws us something that shatters our expectations entirely. A few years ago, an object designated 3I Atlas tumbled into our solar system from the interstellar deep. And it didn't just break the rules, it shattered them. At first, astronomers logged it as just the third interstellar visitor ever detected. A fascinating but understandable event, one that could be placed alongside objects like 1I Oumuamua and 2I Borisov. The cosmos, after all, should occasionally send us pieces of other star systems, wandering rocks and frozen relics dislodged long ago. But when they pointed the Hubble Space Telescope at it, what came back was an impossibility. The object was shining nearly 200 times brighter than 2I Borisov, the last interstellar comet we saw, even though it was at a similar distance. That kind of brightness is a huge red flag. For a comet to be that brilliant just by reflecting sunlight, it would have to be absolutely enormous. We're talking tens of kilometers across, almost 12 miles wide. An object that big is supposed to be a once in tens of thousands of years visitor. The odds of one showing up now were astronomically low, but the size wasn't even the weirdest part. The thing nobody tells you is that the quality of the light was all wrong. Instead of a classic streaming tail trailing behind it, Hubble images revealed a tight compact glow gathered in front of the object facing the sun. This is where the story goes from a scientific curiosity to a world-changing revelation. A team of scientists analyzed how the brightness faded with distance from the object's core. For normal comets, the dust cloud scatters sunlight in a predictable way. But for 3I Atlas, the light dropped off dramatically fast with a mathematical slope of -4. This isn't a number you find in nature for reflected light. It's the signature of a light source that is self-contained, a glow coming from a central point within the object itself. This is when Harvard scientist Avi Loeb and his colleague Eric Kido dropped a bombshell on the scientific community. They proposed a radical new hypothesis. What if the light wasn't reflected at all? What if it was artificial? They argued that the steep brightness profile was a perfect fit for a scenario where dust surrounding 3I Atlas was being illuminated from within. If the object was self-lit, it didn't need to be a 12-mile-wide monster. It could be tiny, less than a football field wide, and still produce the incredible glow that Hubble saw. But to do that, it would need a phenomenal amount of power. Around 10 gigawatts, the equivalent energy output of 10 nuclear reactors converted into pure light. The first sign of something artificial wasn't a radio signal. It was a phantom light in the void. What could possibly power such a tiny object to shine so bright? No gas, no dust, no dice. Many people are crazy about finding simple explanations, and the scientific community is no different. Faced with Loeb's extraordinary claim, astronomers immediately went to work trying to prove him wrong. The most obvious answer was a massive unseen cloud of dust. Perhaps the object had violently shed a huge plume of material, creating a giant reflective surface. It's a good theory, but it comes with a major catch. A dust cloud that big, energized by the sun, should also show clear signs of gas streaming away from it. Vaporized ices like water or carbon monoxide. But when they looked, there was nothing. Careful spectrograph studies found no trace of gas. A massive dust plume without any vapor just doesn't line up with the laws of physics. The next logical step was to reconsider the size. Maybe it really was a 12-mile-wide behemoth, a true cosmic monster. But again, the math just didn't work. The chances of such a massive object entering our solar system are incredibly slim. We should see smaller interstellar objects far more frequently. But a giant like that is a statistical nightmare. It would be like finding a blue whale in your swimming pool. It's not just unlikely, it's a sign that your understanding of reality is flawed. So, the natural comet theory, whether big or small, was hitting a dead end. Scientists, however, are a creative bunch. They started exploring more exotic, out-of-the-box natural possibilities. Could the object be lighting up from friction? Perhaps it was hitting a thick patch of interplanetary dust, creating a fiery glow. This idea was dismissed almost immediately. The space where 3I Atlas is traveling is a near-perfect vacuum, far too thin to cause any significant friction or heating. The next wild idea was a primordial black hole. These are hypothetical microscopic black holes left over from the Big Bang. If one passed through a dust cloud, it could theoretically generate light. But the numbers didn't add up. The power output would be in nanowatts, a billion times weaker than the gigawatts needed to explain the glow. The last desperate hope for a natural cause was radioactive debris. What if 3I Atlas was a fragment of a planet that had been torn apart by a dying star? Such a fragment could be rich in radioactive elements glowing from decay. But for this to work, the fragment would have to be almost pure concentrated radioactive material, a so-called radioactive bomb. The probability of such an object forming, surviving its journey through interstellar space, and then being spotted by us is practically zero. Every natural explanation they threw at the problem failed. One by one, the conventional theories were ruled out, leaving only Loeb's unsettling hypothesis standing. With every natural door closed, only one unbelievable door remains open. A path of intent. The thing is, when you eliminate the impossible, whatever remains, however improbable, must be the truth. And the improbabilities surrounding 3I Atlas don't stop with its light. Its journey through our solar system is just as strange. Most interstellar objects should come in at random chaotic angles. But 3I Atlas is different. Its trajectory is almost perfectly aligned with the ecliptic plane, the flat disk-like region where all the planets in our solar system orbit. It's like a car merging onto a highway and immediately falling into perfect sync with the flow of traffic. It's a 1 in a million coincidence that makes you wonder if it's a coincidence at all. But the path gets even stranger. The object's trajectory appears to be fine-tuned for a tour of our solar system with close passes to Mars and Jupiter. And here is the ultimate twist, the detail that feels like it's straight out of a movie script. When 3I Atlas reaches its closest point to Earth, the point where we could get our best look with our most powerful ground-based telescopes, the Sun will be directly in the way. For that crucial window of time, it will be completely blocked from view, hidden by the glare of our own star. Is this just another incredible coincidence, or is it a deliberate cosmic blind spot? For those who lean towards Loeb's theory, this feels like a calculated move, a way to observe without being too closely observed. So, what does this all mean for us? The people looking up and wondering what's out there. Are we watching a random piece of space rock perform a 1 in a billion cosmic circus act? Or are we missing a key detail? The truth is, we are on the verge of finding out. On October